Hello friends, grab your coffee and maybe a cookie, because today's topic definitely goes down easier with snacks. We're talking about cement dust, the kind of dust that appears faster than you can close the airlock and behaves like it is the boss of your facility. My name is Michael Klepik. I have been living around dust collectors and air filtration systems for 15 years, and today I will explain everything in a simple and clear way. What cement dust really is, the engineering view. Cement dust is a mix of mineral particles made of calcium, silica, aluminum, and iron. The size of these particles usually ranges from 1/10 of a micron to about 50 microns. The main active fraction is from 1 to 10 microns. Here's why this matters. First, particles smaller than 10 microns easily enter the lungs. Second, particles smaller than 2.5 microns go even deeper and increase health risks. Third, the particle surface is rough, which makes the dust behave like an abrasive. Fourth, cement dust absorbs moisture and forms clumps. There is one more important property. Cement dust is alkaline. Its pH level is usually between 11 and 12, which means it can irritate skin, eyes, and respiratory pathways. Where cement dust forms and how heavy the loads can be. Let me list the dirtiest areas in a cement plant. First, crushers. Peak concentrations can go from 10,000 to 40,000 milligrams per cubic meter. Second, ball mills. Typical concentrations range from 5,000 to 15,000 milligrams per cubic meter. Third, pneumatic transport lines. Any air leak instantly throws dust into the workspace. Fourth, silos. Loading operations can release up to 25,000 milligrams per cubic meter. Fifth, bagging and packaging machines. These zones generate the finest dust. Sixth, conveyor transfer points. A dry belt almost guarantees a visible dust cloud. For cement dust, I normally set the duct transport velocity from 3,500 to 4,200 feet per minute. If the air moves slower than that, the dust begins to settle and blocks the ducts. How I choose the right filter for cement dust. There are two key factors. First, the dust concentration is high, which means the system must withstand heavy loading. Second, the dust is abrasive and dry, so the filter media must be dense and durable. In most projects, I specify polyester filter media with a density from 550 to 600 grams per square meter, with anti-static properties and resistance to moisture and oils. If the dust includes very fine particles, I often use a PTFE membrane layer. Why the BagHouse Blizzard is the best option for cement plants. In about 90% of cement applications, I install a BagHouse filter. Here is why. First, a BagHouse can handle extremely high loadings and abrasive dust. Second, pulse jet cleaning works very well on cement dust. Third, it is reliable, serviceable, and economical. The Blizzard BagHouse from Torch Air is like a dependable pickup truck. It does not complain, it does not break easily, and it simply gets the job done. In most systems, I use pulse cleaning pressure from 80 to 100 pounds per square inch. The working pressure drop usually stays from 3 to 6 inches of water column. The filtration velocity I set from 3.5 to 4.5 feet per minute, which is the sweet spot for cement. If the incoming dust concentration is very high, for example from 20 to 40 grams per cubic meter, I almost always include a cyclone pre-separator. It removes from 50 to 70% of the dust before it reaches the filter bags, extending their life 2 to 4 times. Leverage tools to streamline your strategy. Use scheduling apps for consistent posting. Design software for engaging visuals, and analytics platforms to track and improve performance. When a faux-end cartridge collector can work, cartridge collectors perform very well, but only if the dust is completely dry. They offer several advantages. First, a large filtration area. Second, a compact housing. Third, excellent performance on fine particles. However, if humidity rises, cement dust begins to clump and cartridges plug quickly. That is why I use faux-end collectors only on dry transfer points, packaging stations, or small local capture zones, when a faux-end cartridge collector can work. The most common mistakes I see in cement dust systems. Across many facilities, I see the same issues repeated. First, insufficient air velocity in ductwork. The ducts eventually fill up with compacted dust. Second, incorrect hopper discharge settings. If the rotary valve does not cycle properly, the filter receives heavy shock loads. Third, undersized filtration area. When a filter works at its limit, the pressure drop increases and dust starts to leak through the media. What I always do on cement projects: first, I install a differential pressure sensor to track filter condition. Second, I use a cyclone or another pre-separator if the dust is heavy. Third, I check the real fan performance, not just the label rating. Fourth, I set pulse cleaning based on differential pressure, not on a timer. Fifth, I design proper hoods and enclosures at transfer points so the dust enters the system instead of escaping into the facility. A good hood can sometimes reduce the cost of the entire system simply because the dust capture becomes efficient. Cement dust is a challenging material. It is fine, abrasive, alkaline, and extremely airborne. But when you select the right filtration system, set proper duct velocities, and design the capture points correctly, the system runs smoothly and consistently, like a good diesel engine at idle. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, the only place where dust should fly is inside your filter, not in your workspace. See you in the next video.